SIP9 Hub.
Hi, welcome to another episode of SIP9 Hub. In this presentation, we will be talking another summary measure. It is called the measure of skewness.
But before we continue, do not forget to like this video, hit the subscription and notification bell to stay updated of future videos.
Skewness refers to the departure from symmetry of a given distribution. Statistically, we are comparing whether the mean is greater than the median or the median is greater than the mode or the other way around. There are three cases that we are going to study under skewness. We start with the normal distribution. This is the distribution that is not skewed at all. If we are going to look at the graph, the left part of the graph is a reflection of the right side. They are just the same. And the values of the mean, the median, and the mode for a normal distribution are just the same. This is the graph of a positively skewed distribution. This is the skewed part and it's moving towards the right side. For a positively skewed distribution, it is actually the right side. If we look at the graph, it's the right side that is being skewed. The mean is higher than the median. This is another case. It's called negatively skewed distribution. The skewed part is found at the left part of the distribution. The mean is actually the lowest among the three measures of central tendency. If the three measures of central tendency are equal, then the distribution is normal. If the mean is the highest, followed by the median, then that distribution is positively skewed. I would like to pose a question regarding our topic in this presentation. I would like you to comment down below your answer before you continue watching this video. Here's the question. Suppose you are a teacher and you administered a 100-point test to your students. My question is, which of the three distribution would you like to be the distribution of the scores of your students in that particular test? Would you like it to be negatively skewed? Would you like it to be normally distributed or skewed positively? To answer that problem, let us give meaning to this graph. Remember that in our y-axis, that is the frequency, and our x-axis, normally these are the scores. If the distribution of the student's score in that particular test is normal, the highest peak happens at what part of the scores? Remember that these are scores. So of course we start from the low scores here, going to the high, going to the middle score. This is the middle score, and then here are our high scores. What this means is that the highest frequency, this is the peak. Remember that the y-axis is our frequency. The highest frequency actually happens at this score, at this value. And what value is this? It's the middle value. Majority of the students got a score that is close to the middle score. In terms of students' performance, we can say that the performance is not too low, not too high, but just average. If this is your answer, you are saying that you want your student's score to be just average. Is it positively skewed? Do we want our students' scores to be positively skewed? Let us first analyze what it means. In this particular graph, the highest peak happens at what part of the x-axis? This is the peak, right? And that happens to this part of the x-axis. What part is this? Is this the part where low scores are found, or high scores are found, or the middle scores are found? This is actually the part where the lower scores are found, because it's heading towards 0, right? The intersection of the x-axis and the y-axis is 0. So that the scores that are close to this number are low scores. And this graph is telling that these scores here, the low scores, are the scores of the majority of the students, hence the highest frequency that we see here. That is why if you wish that the distribution of your students' scores to be positively skewed, then you are saying that you want the majority of them to have low scores. As a good teacher, we want the distribution to be, yes, negatively skewed. Because in this distribution, the peak of the graph happens at the high scores. This means that majority of the students got high scores, and we want this to happen for our students. Computationally, the measure that we use to describe skewness is called the Pearsonian coefficient of skewness, symbol Sk, and this is the formula that we use. Again, we use this value to describe the skewness of a particular data set. X bar is the mean of the distribution, MD is the median of the distribution, and S is the standard deviation of the distribution. If you are working from a population, then we use the population mean, the population median, and the population standard deviation. So it's up to you to identify which is which. Now, after solving for Sk, this is how we are going to interpret those values. Based from this value, we would know if the distribution is negatively skewed, positively skewed, or it's approaching the normal distribution. How do we do that? If the value of Sk is negative, then the distribution is negatively skewed or skewed to the left. The farther it goes away from 0, going to the negative values, the more negatively skewed the distribution will be. If it's positive, then it's positively skewed or skewed to the right. The farther it goes away from 0, going to the positive numbers, the distribution becomes more skewed to the right. If the value of Sk is approaching 0, very near 0, then it is becoming symmetric or normal. In reality, we rarely see a distribution whose value of Sk is exactly 0. Let's provide an example. We have 3 datasets, dataset A, dataset B, and dataset C. Let us explore the skewness of the 3 datasets by computing the value of Sk. Let's start with the first dataset. Again, the formula for Sk involves the mean, the median, and the standard deviation. So before you can compute Sk, we need to compute first for those values. I have already computed those values. For dataset A, the mean is 6.09, the median is 3, and the standard deviation is 6.79. Using the formula for Sk, we substitute these values here. So we have this one, and the result is 1.37. It is positive. This means that the first dataset, dataset A, is positively skewed. Let us verify that it is indeed positively skewed. Remember, positively skewed distribution means that majority are low scores or values. If we look at our distribution, we can indeed see that more values are lower compared to the highest numbers in the distribution. For dataset B, the mean is 16.27, the median is 17, and the standard deviation is 3.58. If we substitute these values in our formula for Sk, the value is negative 0.61. It's negative, therefore dataset B is negatively distributed. Again, negatively skewed distribution means that majority of the values or of the scores are high. In fact, we can actually see only one of them that is a bit low as compared to the majority of the numbers here. For dataset C, the mean is 17, the median is 17, and the standard deviation is 1.41. If we substitute these values in our formula, the result would be 0. 0 is the value of Sk. Although I mentioned a while back that it's rare to see a dataset whose Sk is 0, this is because these are just hypothetical data. If we look at the graph for the different distributions, this is what it looks like. Although we can see bar graphs here, if we imagine that we draw a line from the origin following the bar graph, we could imagine that the skewed part is indeed found at the right side of the graph. For dataset B, if we start here, we could imagine that the skewed part is indeed found at the left part. I know what you're thinking about this graph, but that is just a mere coincidence. If we're going to imagine a line here, that would be the graph of our normal distribution. That's it for our measures of skewness. Thank you for listening.